All right, so Cisco Discovery Protocol, as I said, now let's say an example. If we talk about the example, so let's say if I have a switch connected, oh, this is yellow. This is one switch, below other switch, and below to this another switch. Okay, so using CDP protocol, using CDP, it can discover who are my neighbors. Okay, this switch here, I can run a command and check it out who are my neighbors. So it will automatically discover the neighbor devices, but it should be Cisco. Okay, so whatever all Cisco devices are near or directly attached to this device, it will discover. So if I run this command here, it will discover this and this. If I run here, it will discover only this because it is neighbor, that means directly attached device. Similar way, this is for Cisco proprietary, but for non-Cisco, we have a LLDP. Okay, link local discovery protocol. That means that actually discovers you non-Cisco equipment, non-Cisco devices. For example, let us take it. Let us check here. Okay, now let's say if I take any switch, this is one switch, below I have this switch, I can have few routers also. Okay, ये है, now let it boot. Show CDP neighbors and enter. Okay, so this is a router because until I don't enable or put the IP address, this port will not come up. F0 and 1 and 2. Config T. Interface range F0/1 and 2. Switch port, trunk, encapsulation, and .1Q. This is one command. Switch port mode, trunk, exit. Done. This is one thing. And on the other switch, this is layer 2. So what you need to do, int f0/1. Switch port mode, trunk. Okay, now check here. Show CDP neighbor. Look at this. Your switch is appearing now. Who is a neighbor? This one. It is telling you which is the platform, which is the model, this one. Now if you go here, this is a router. Config T interface is 0/0, or what it is, F interface F0/0, no shutdown. Now it will discover this also. This port should come up first, then it will start discovering this device also. So this is a CDP command. CDP protocol is basically to discover your neighbors. Who are your neighbor? It can discover automatically. It can find out automatically. Let's this port come up. It will tell you the platform as a router. Look at this. It started discovering that. Okay, so F0/2. Okay, and it is C2800. It is saying that this is a router device. Capability is a router. So this is CDP. Now I by default on your all switch port CDP protocol is enabled. So if you want to see switch port, no, not that, show CDP interface. So look at this, on all the ports your CDP is by default enabled. So all ports are appearing, whichever port is appearing, that means CDP is enabled on that. If on any port CDP is disabled, then that port will not appear here. That port will not appear here. Sending CDP packets of every 60 second, hold down time is 180 second, like that. Okay, so this is only the CDP protocol. Now coming back to the core topic, that is Ether channel. Ether channel is very important topic now. Okay, so this is actually a very big way. It is into in detailed way. It is there into CCNP, and in this new syllabus they have brought up an Ether channel topic as well. Okay, so now what is this Ether channel and what's the purpose of this? That is the questions. So try to understand. Let's say you have any switch. I'm deleting this one now. Okay, so scenario is, let's say I have two switches here, and switch has got a fixed port always. Okay, any switch example, if you take double click, physical, this is a switch. So your switch has got a fixed port. Okay, the ports are fixed. Now all this port, assume that all of your ports are, all of these ports are, let's say 100 Mbps. All these ports are 100 Mbps. Now I want to connect one switch to the other switch. So let's say from this port I want to connect another switch. Okay, so I want that this uplink, This uplink which connects switch to switch, it should be more than this general ports. All right, because let's say many ports, if many computers want to send data to the other switch, then this link capacity should be other than these all ports. This should be like that. Okay, so what can we do? The switch devices are fixed. You cannot change port, you cannot replace port, you cannot do anything. Okay, now then what is the other best solutions to get the higher speed? यदि आपको higher speed चाहिए तो दूसरा solutions क्या है आपके पास? आपके पास दूसरा solutions ये है कि you will connect two switches. Okay, and probably you will connect this by two links. अब मैंने ये दो switches दो link से connect कर दिए. अब आप देखो क्या होता है. एक ही link on होगा. ओके, लेट इट कम अप. एक ही लिंक ऑन होगा, एक हमेशा डाउन रहेगा. लुक एट दिस विल बी ऑलवेज डाउन. वन लिंक इज ऑलवेज डाउन. एक तरफ का कोई भी डाउन है मतलब वो लिंक डाउन है. ऐसा क्यों होता है? ऐसा इसलिए होता है क्योंकि राउटिंग में मैंने बताया था कि यहाँ पर क्या प्रॉब्लम्स है, किस चीज की पॉसिबिलिटीज है. लूप की पॉसिबिलिटी है. यदि दोनों लिंक अप होते हैं तो लूप कैसे जनरेट होगा? कोई भी पैकेट ये स्विच इस पोर्ट पर भेजेगा तो वो यहाँ पर जाएगा, इस स्विच से वापस एडवर्टाइज होके इधर आ जाएगा, इधर से वापस एडवर्टाइज होके इधर आ जाएगा. ऐसे यहाँ पर लूप क्रिएट हो जाएगा. इट विल क्रिएट ए लूप. तो इस लूप को अवॉइड करने के लिए बाय डिफॉल्ट क्या करता है, सिर्फ एक ही लिंक को अप करता है कि यहाँ से पैकेट आया तो किसी दूसरे लिंक से वो वापस न जाए. This is the loop prevention mechanism called STP. We will see STP in detail. ओके, तो एसटीपी के कारण आप एक टाइम पर एक ही लिंक यूज कर पा रहे हो. तो मैंने दो लिंक इसलिए लगा दिए कि भाई ये 100 एमबीपीएस का है, ये 100 एमबीपीएस का है, दोनों मिलकर 200 एमबीपीएस हो जाए तो आई कैन यूज इट्स 100 प्लस 100 200 एमबीपीएस की बैंडविड्थ बन जाएगी. बट आइडियली ऐसा नहीं हो रहा है. तो ये टास्क अचीव करने के लिए क्या बनाया? एसटीपी, सॉरी, ईथर चैनल बनाया. ओके, सो व्हाट इज दैट ईथर चैनल? ईथर चैनल अब क्या करता है? ईथर चैनल अलाउज यू टू बंडल दिस टू पोर्ट्स लॉजिकली. फिजिकली ये दो पोर्ट्स हैं, ये क्या करेगा? लॉजिकली इन दोनों पोर्ट्स का एक बंडल बना देगा. और अब ये दोनों पोर्ट्स एक ही जैसे लॉजिकली अपीयर होंगे. और अब ये 100 और 100 200 का एक ये पूरा आपका पाइप कैपेसिटी बन गया. So this is actually ether channel. Okay, now let's understand what this ether channel actually. So ether channel is a technology allows to bundle multiple ports and allows to bundle multiple port, and what it does is again and let's say aggregate link bandwidth. Okay, it bundle multiple ports and aggregate the links bandwidth into one, that is ether channel. Okay, that technology basically called as an ether channel. Okay, now we understood what is ether channel. Now we can bundle up to 8 ports in one ether channel. Okay, we can bundle 8 ports, up to 8 port into one ether channel. All right, now when we want to bundle, when you want to club multiple ports into one and create one logical channel, there are certain settings which must be same. There are some settings which must be same. So what settings? So all ports All bundle ports, you mean? All bundle ports must be part of same VLAN. ओके, लेट्स से एक पोर्ट किसी और VLAN का मेंबर है और दूसरा पोर्ट किसी और VLAN का मेंबर है, तो काम नहीं चलेगा. ओके, नाउ यू कैन अज्यूम दैट, लेट्स से ये आपने बंडल बनाना है, ये पोर्ट VLAN 1 में है, ये पोर्ट VLAN 2 में है, सो देन इट विल नॉट वर्क. बोथ पोर्ट शुड बी इनटू सेम VLAN, एक ही VLAN में होना चाहिए, 1. सो दैट इज द फर्स्ट प्राइमरी रिक्वायरमेंट. सेकेंड रिक्वायरमेंट क्या है? ट्रंक मोड should have same trunk mode. दोनों ही पोर्ट का ट्रंक मोड क्या होना चाहिए? सेम. मैंने ट्रंक मोड बताया, ISL इंटर स्विच लिंक एक है और IEEE 802.1q ये दूसरा है, तो दोनों पर ट्रंक मोड सेम होना चाहिए. ओके, नाउ नेक्स्ट वन इज should have same duplex and same speed. ओके, अब दोनों पोर्ट्स की स्पीड और ड्यूप्लेक्स सेम होनी चाहिए. फॉर एग्जांपल लेट्स से यदि ये एक पोर्ट आपका हाफ ड्यूप्लेक्स में है और दूसरा फुल में है, तो ईथर चैनल बनेगा ही नहीं. दोनों हाफ हाफ में ही होने चाहिए. ओके, एक हाफ में है एक फुल में तो नहीं, या तो दोनों हाफ में होने चाहिए या दोनों फुल में होने चाहिए, ऐसा. दोनों का मोड जो है सिंपल ड्यूप्लेक्स का वो सेम होना चाहिए और स्पीड भी दोनों की सेम होनी चाहिए, मिसमैच स्पीड नहीं होनी चाहिए. These all are few requirements. Okay, these all are few requirement. ओके, अब नेक्स्ट क्वेश्चन इज व्हेन आई बंडल. अब ये दो पोर्ट मैंने बंडल कर दिए, तो अब जो भी डेटा मैं भेजूंगा ये दोनों पोर्ट पर डिवाइड होकर जाएगा. अभी देखो, अभी तो इथर चैनल नहीं है इसलिए एक डाउन ही रहेगा. तो ये ट्रैफिक कैसे डिवाइड करेगा? ओके, ट्रैफिक डिस्ट्रीब्यूशन इज बेस्ड ऑन सोर्स मैक और डेस्टिनेशन मैक, सोर्स आईपी और डेस्टिनेशन आईपी, आईपी और पोर्ट base. Okay, so your traffic distribution is based on the source MAC address or destination MAC address or source IP address or destination IP address. Yeah, it is based on that. Okay, and they are the fixed algorithm in the switch that you need to choose which algorithm you want to use. That is completely your choice, and every switch has got a different algorithm there. Okay, all right, this is one thing. Now, next one is Ether Channel Negotiation Protocol. Ether Channel Negotiation Protocol. Okay, so now I decided to create a Ether channel, and let's say we have made this Ether channel. So how this Ether channel will be created and how it will be configured? So to configure this Ether channel, there should be a protocol. Okay, there should be protocol enabled here and protocol enabled here. So there are two types of protocols available. One is PAGP, port aggregation protocol. This is one protocol, and another one is LACP. Okay, LACP, link aggregation control protocol. So these all are two different types of protocols available there. Okay, port aggregation protocol and link aggregation control protocol. So port aggregation protocol is outdated now. That is a Cisco proprietary. Now we are using nowadays LACP, link control aggregation protocol, which is open standard. If this is Cisco and this is something else also, it will work. So that is link aggregation control protocol. Okay, so we have a two protocol, PAGP port aggregation control protocol, and LACP, link aggregation control protocol. Okay, this is only port aggregation protocol. Okay, so now port aggregation protocol, aggregation protocols we will discuss, because that is PAGP is gone now. Okay, so LACP, it's a it's a open standard. Open standard protocol, that means one device is a Cisco, other device is non-Cisco. In between them also you can use this LACP. Okay, its IEEE standard is like 802.3AD. Okay, so if you want to know about LACP, that means it is 802.3AD, IEEE standard name. All right, this is okay. Now LACP has got a system priority. LACP system priority. What is that system priority? System priority is 1 to 65,535, and default is 32,768. What is that system priority? Let's understand. Okay, now system priority, that means let's assume that I have a LACP. Okay, so I have LACP enable. So who will take a ether channel decision? This switch will take decision, or this switch will take? So whichever switch has got, okay, the one switch to be assigned to a lower system priority than the other, so that it can take a decision. So by default your system priority is, let's say, 65,535. If I give here 65,530, this is lower, so this one would be decision maker. This one would be the decision maker switch. So whichever switch has got a lower system priority will be the decision maker. Okay, if I don't set any priority, both has got the same priority, then what? If both switches has got the same priority, then what? Then the switch with the lower MAC address. Lower MAC address. Out of these two switches, whichever switch has got the lower MAC address, that will become a decision maker switch. Okay, if priority both has got same, so this switch has got a MAC address, this switch has a MAC address. So which switch has got lower MAC address will become the decision maker. Understood? All right, this is okay. Now there is a port priority as well. Now let me write down this first. Switch with the lowest system priority become, okay, switch with the lowest system priority become the decision maker. Okay, all right. Now if both switches has same priority, then switch with the lowest MAC address become, decision maker. All right, this is the one. So that's all, nothing much about this. Now let us see the practical now. Okay, so we have this two switches now, let's say, and I want to make a ether channel so that this link also should become the become the up, and it should become 100 plus 100 or 10 plus 10 20 or 100 plus 100 200. It should become the bundle link. So how to do it? Very simple. Now let's go to the switch, enable config T. Now if you want, if first of all I need to set the load balancing method. So port channel, load balance, and question mark, put the question mark. So these many load balancing methods you have. So I will prefer to have a source MAC. I'll pick source MAC. Okay. So this is a first command to do the to set the load balancing method. Okay. Now next is, now you are creating an ether channel. So you need to go to the interface range. I will choose both the interface. So F0/1 and 2. So I have done this. Then now channel protocol. Channel protocol LACP. Okay. So I have defined channel protocol, then channel group. Channel group. Now 1. So you are creating channel 1, channel 2, channel 3, like that. You can create many. So channel group 1, and then I will define the mode. So which mode you want to keep? Put the question mark. Look at this. So for LACP, you have a active, you have a passive, and you will have a on. So I will put an active. Okay, this is done. Okay, then no shutdown. Exit. Okay, so you have a this command. Then you have this command. Then you have this command. And then no shutdown. This is now same thing you need to do on the other switch. Let me go to the switch 2. Enable. Oops. Yeah, you need to wait till this come up. What happened? Okay, now it is there. Enable config terminal host name SW to switch to. Now, very first thing, port channel, load balancing, and source MAC. First command. Second command is interface range F0/1 and 2. Switch port, no, not that. Uh, Channel protocol. Channel protocol LACP. Channel group 1 and mode active. Done. Exit. Same command at the other switch as well, no change. Now you see what happened. Both the links should become up. Let's wait. Okay, let that port come up. Okay, look at this. Both the links are up now. Okay, and let's see now here. Show IP interface brief. Look at this. You will see one ether channel has been created there. Oh, where is that? This is first port channel 1. It is up and up. Now what is the capacity of that port channel? Show interface port channel 1. Look at this. Here if you see, the capacity is 300. So if your one channel is 150, 150 plus 150, 300 MB. It is like that. If one channel is 1 GB, so 1 GB plus 1 GB, you will get 200 GB capacity of that port channel. Okay, so like that. Okay, now I can make here show ether channel summary. Look at this. What it is telling you, port channel 1, capital S, capital U. Capital S, what capital S is indicating here? Capital S is indicating layer 2 and capital U is in use. LACP port P, what P is indicating here? Port in, port channel. Okay, show ether channel detail. Not there. Okay, so here in this way also you can check it out. So now I have not configured detail commands is not there. This in this simulator there are few commands which are not working, but there is a command. Okay, show ether channel detail. So using that you can check, okay, who is your decision maker. So by default your decision maker would be this switch. Now I want to make this switch as a decision maker. So you can reduce the system priority. So how to reduce the system priority? All right, so simple way, you have to be config in config mode, LACP, and here the simulator doesn't have a command, LACP, and you need to give a command system priority and give whatever priority. Okay, 65,500, let's say 30. So this switch has got a lower system priority, so this switch will become, switch 2 will become the decision maker now. So using this you can change the priority and make the switch as a decision maker. Okay, so whichever switch has got the lower system priority, that switch would be the decision maker switch. Okay, like that. So this is what we have created, a ether channel. Now both the links are up and there will be no loop because the switch will see this two ports bundle as a one link. Okay, it will not see as a two link. So whatever it is advertising, by considering as a one link only, it will advertise. So it will advertise the anything considering as a one link here. Considering as a one link. Okay, so there is no chance of loop. Perfect. So that is ether channel, guys. Now you have to do this. You have to practice. Any queries, you can ask me if you have any queries here. You can add up to 8 ports in one ether channel. Anyone has got a question, guys, you can ask me. No one has got a questions?